All right, in this third part of the lab, we're looking at capacitors and how capacitors work within a circuit. Before we get to the RC circuit part, I just want to show you briefly how a capacitor actually works. We've seen what they look like in the PowerPoint slides. So this is an actual capacitor, and this has a capacitance. Let's see if you can read it here, of 1.0 F. So we're looking at right there, 1.0 F. So this is a 1 farad capacitor. Makes the math kind of nice and easy. So it's a 1 farad. And it has two legs on it, and you can see that one is longer than the other. So this is the long end. These capacitors are designed so that the long end always has to connect to the positive charge, and the negative charge connects to the short end. So that's something important to keep in mind. I want to connect negative to short, positive to long. I have a slightly different battery here. This one has two 1.5 volt D-cell batteries, and I've connected them together so they are in series. So this is the positive end of this battery. This is the positive end of this battery. So the positive is connected to the negative here. And then that makes this one big battery of about 3 volts. So if I take the negative side, connect it to this side of the capacitor, and the positive side, when I connect the positive side here, it will charge very fast. And it'll charge fast because there's no resistance in the circuit, so as much positive charge as needs to will go onto the one side, and as much negative charge as needs to will go to the other side until the voltage here matches the voltage there. So I'm going to just connect it for a second, leave it here. So I've got positive, negative. This should be fully charged now. And so now I have energy stored inside this capacitor. And I'll prove that to you with this light bulb here. So when I take this, disconnect it, now it's not connected to the battery, and I'll just put it over here for a second. I can show you that this voltage can light up this light bulb. So that amount of voltage here can light up this light bulb. But now this is storing the same amount of voltage as that is. And so I can use this also to light up the battery. But what you'll see is that once it connects, the charge will go through, and as it goes through, eventually it will run out. And you'll see the light bulb get dimmer and dimmer and dimmer as this runs out of energy. So it stored up the voltage, and as charge distributes back to equalize, it eventually runs out and the light bulb goes out. And just to make sure it's totally discharged, I can connect the two ends, and then any charge will equalize. Now with capacitors of this size and using these voltages, I'm not going to get hurt. If I was dealing with like hundreds or thousands of volts, I certainly wouldn't with my hands just connect these together like this. But I know this is you can handle D-cell batteries without damaging anything because the voltage is relatively small. And the same is true here because it has the same voltage as there. Okay, so now this is a completely discharged capacitor, and we can charge it up again. We can charge it up again using this battery. So again, I'll connect negative to short, positive to long, and we'll let this charge up. Now this just adds a little bit of resistance to really slow down the charging, discharging. What we can do is use an extra resistor. So this should be fully charged now, and I'll take one of the 100 ohm resistors. Again, we'll always check the resistance, not just trust that it is what it says. Put it over to measure resistance. So what is our resistance? Our resistance is 102.5 ohms. Okay, turn that off, put this to the side for a second. And now let's see what the battery voltage is. Sorry, not the battery voltage. Well, I guess it's the same, but the capacitor voltage. So negative to negative, positive to positive, and I'll put it onto the voltage measurement here, and we'll see how many volts there are across this capacitor. 2.94 volts. So this capacitor charged to 2.94 volts. That's our initial starting voltage. Okay, so now what I'm going to do is put this into a circuit, and the circuit is going to be from the capacitor through the resistor and back to the capacitor. So I'm making a little circle here. As soon as I connect it, charge is going to start flowing back through here and equalizing. I can get rid of the battery so it's less confusing. And I want to monitor the voltage across the capacitor as it goes. So I will connect the voltage meter back up, and I'm connecting it in parallel. And you'll notice the voltage has already dropped a little bit. And so I'll use whatever this is at the starting point as my starting voltage, or you will use whatever the starting voltage is, because there's going to always be some leaking of charge, and so the voltage will drop as it just sits here as I'm talking. But what we're going to do is watch the discharge, and when I finally make this connection, that's when the clock starts. And so the job is to record this voltage over time, and you can use the time on the video and record that as the official time, and then what the voltage corresponds to at each unit of time. So when I connect this, right now it's at 2.67, it'll probably drop 2.66, and I'm gonna connect. Okay. And so now you see that it's dropping, and as it's dropping with time, that dropping is going to be faster at the beginning, and eventually it will slow down. And it'll take a while for all of the charge to equilibrate from one side of the capacitor to the other, because now it has to go through the resistor. There's some resistance in the circuit. This is an RC circuit. So you can record periodically what this voltage is at any time, starting from the moment that I completed the circuit. And so I'll just let this run, and what you'll want to do is collect data periodically, more so at the beginning than towards the end. So you want a lot of data points at the beginning, and then after a while you can just wait 15 seconds, 20 seconds, 30 seconds in between data points. But we're going to try to get this down. So this is measuring voltage across the capacitor. We'll let it discharge down until it's, let's see, less than 0.1 volts. And once it gets to 0.1 volts, you can stop your data recording. Okay, so there we are. We dropped below 0.1 volts. So you can stop collecting data at this point. We've got the discharging from up over, I think it was 2.6 volts down to 0.1 volts. And the data that you collected will have the voltage versus time and should show a nice exponential decay. From that, you can extract the decay time, which should be just the resistance times the capacitance that we have. So this resistor times this capacitor gives you the overall decay time, and that should be reflected in the exponential decay that we see here.